Recall that to integrate by substitution, we basically reverse the chain rule of differentiation. We can also make a method of integration using the product rule of differentiation. So remember that the derivative with respect to x of f of x times g of x is f of x times g prime of x plus g of x times f prime of x. And if we integrate the right-hand side, we should get f of x times g of x plus some constant. So taking that equation and rearranging just a little bit, we get the integral of f of x times g prime of x dx equals f of x times g of x minus the integral of g of x times f prime of x dx. Or in shorthand, the integral of u dv equals u times v minus the integral of v du. And of course, if we're applying the definite integral, then we need to evaluate at the endpoints. Let's try an example. We'll use the colors just to keep track of what's u and v here in this particular example. So let's suppose we want to integrate x times cosine 2x dx. Now the first thing we have to do is choose a u and a dv, and the u should get simpler with differentiation, powers shouldn't increase, and the function shouldn't get more complicated. And of course we should be able to integrate the dv we choose to get v. So let's choose u equals x. That certainly gets simpler when we differentiate it, and we can integrate cosine 2x dx, so we'll let that be dv. So now du is 1 dx because du dx is 1, and v is the antiderivative of cosine 2x. And you can use substitution to figure out that that's sine 2x over 2. Now plugging this into the formula, we have the integral of u dv equals u times v minus the integral of v du. And notice that when I calculated v, I didn't add the constant of integration. And you can figure out for yourself that if I add a constant here to the v, say perhaps add 2, that constant will cancel out on the right-hand side of this equation. Now tidying up, we have our integral equals x times sine 2x over 2 minus 1/2 the integral of sine 2x dx, and the integral of sine 2x is minus cosine 2x over 2. And again, tidying up, finally we get our integral is x times sine 2x over 2 plus cosine 2x over 4 plus some constant. Now for the definite integral, we need to evaluate at the endpoints. You might ignore the endpoints and use integration by parts, and then when you find your antiderivative, then just plug in evaluate f of b minus f of a, or you can also carry them in the calculation. So suppose we want to integrate x e to the x from 0 to 2. Well, now again, if we let u equal x, it does get simpler when we differentiate, and we can integrate e to the x easily. Choosing u equals x, we get du equals dx, and dv equal to e to the x dx gives us v is e to the x. And now using our formula with a equals 0, b equals 2, we have the integral from 0 to 2 of x e to the x dx is equal to x e to the x evaluated between 0 and 2 minus the integral from 0 to 2 of e to the x dx. And working on the right-hand side, first we evaluate at the endpoints here to get 2 times e to the 2 minus 0 minus the antiderivative of e to the x is e to the x, and we evaluate at the endpoints 0 and 2 there. So finally we have 2 times e to the 2 minus e squared minus e to the 0, which is 1 times e squared plus 1.